Hi everyone, this is Team 2, and today marks our 7th presentation on the construction of the Cadet Chapel. This week, we're going to begin by answering our feedback last week and go further into the details of the construction. First of all, to give a short recap, our building consisted of two main structures, the interior building and the roof. We gave a presentation on the construction of the interior building, but then realized we lacked few of the important details such as the rebar placement, the origin of the columns and beams, the type of concrete used, and the purposes of the interior walls in the building. So let's begin with the rebar placement. Our foundation is built using caisson foundations, where the load is transferred from it deep into the ground. However, in order to transfer the building's load to the caisson foundations, another concrete base is needed to be constructed. Not just any concrete, but reinforced concrete. Rebar placement refers to the process of placing steel reinforcement bars before pouring concrete to enhance the strength, stability, and durability of structures such as slabs, columns, beams, and foundations. So for our building foundation, we need to decide how to place the rebar. Looking at the chapel's blueprints, we noticed two red rectangles at the bottom, which we interpreted as the foundation with the rebar placement. This type of rebar placement falls under a category called combined foundations. Well, what is a combined foundation? Combined foundations refer to a method of supporting the load from two or more columns with a single foundation slab. It's particularly effective when the space between columns is narrow. In our building, when columns are close together and carry most of the load, it's better to concentrate the rebar in certain spots rather than spreading it all over the foundation. Since we already have caisson foundations that handle the vertical load, we can use combined foundations to spread the load horizontally. This way, we can reduce the number of caisson foundations needed. First, let's look at the overall groundwork. On land, where the building cannot be constructed, the rebar process is not needed, so we installed a retaining wall and filled in the backfill, which consists of materials like sand, gravel, and soil dug up from the site. We then added a 50mm layer of concrete on the construction floor to level it and prevent moisture or concrete from going into the ground, keeping the concrete strong. Before pouring the extra concrete, we thought about using a plastic sheet to stop mixing with the soil. After leveling the floor with concrete, we added steel bars according to the blueprints and secured them. This mix of concrete and steel makes the foundation stronger. In our steel concrete class, we learned that steel bars help reinforce the weak parts of concrete. We had to space the bars correctly. If it was too apart, the support would be weak. Conversely, if it was too close, the concrete wouldn't fill properly. Typically, bars are spaced 1 meter apart horizontally, but ours were closer at 70 centimeters because we had a heavy load to support. And above the first layer of bars, we added another layer to handle the pressure on the ground, while the bottom layer dealt with tension. Let's simplify the process for the Cadet Chapel foundation. Because the foundation is bigger than usual, we used thick 40mm diameter steel bars between points D-35 and 38 for extra strength. We started by placing the lower bars first because it's easier to work from the bottom up. Then we added vertical bars with bent ends to keep everything stable. We tied the joints of the bars together to make sure they stay in place while we pour concrete. When the lower bars were set, we added the upper ones. But sometimes the bars weren't long enough for the whole foundation. In that case, we overlapped the ends of the upper and lower bars to connect them, keeping everything secure when we pour more concrete. In the chapel columns, the rebars are divided into two main parts, the vertical main steel bars and the horizontal tie bars. The main bars are bent at a 90-degree angle at the bottom for stability. The tie bars are tightly connected to each other to prevent movement. Tie bars are important because they help the main bars resist bending. During construction, the lower reinforcement is bent at a 60 to 90 degree angle under the foundation reinforcement to support it and prevent movement. This is how the upper and lower bars were arranged. After the main reinforcement for the pillar foundation is done, a strip reinforcement was added to prevent the main reinforcement from buckling or shearing. This protruding part of the caisson foundation, which we talked about last week, is called the head. It is cut to prevent the caisson foundations from being damaged and is then separated between the rebars to prevent the intrusion of other materials. This leads to an effective connection of the upper concrete foundation with the pilings and prevents damage to the pile or penetration of concrete during the pouring process. Formwork along the perimeter of the rebar was further installed in order to pour unset concrete around the rebar, creating a temporary supporting structure until the concrete reached the desired strength, shape, and size. We then poured concrete onto the prepared foundation and built the column footings. The reason for constructing footing and then columns is in order to easily install framework, place reinforcement, and pour concrete for the columns and walls. This enhances safety and efficiency during construction, and this process involves setting up a formwork and then pouring concrete in the same manner. The final phase of the foundation is filling soil around the perimeter and compacting it, using equipment such as cranes and compactors. This process is repeated in order to further stabilize the foundation and prevent settling or tilting of the structure. Using appropriate backfilling materials and methods can also help control water infiltration and excessive moisture buildup around the foundation, improving the overall durability of the foundation and the building. Now that the foundation of the cadet chapel is finally complete, let's dive into the origin of the columns and beams used in the cadet chapel. Remember how we said that the chapel is used for religious purposes and needs a big open space inside? We also mentioned that the building was not that tall, but really long. Therefore, according to the needs of the people using the building, we needed multiple columns and beams that were sturdier and longer than those used in common construction sites in order to create a large open interior space. To begin with, the columns, beams, and girders used in the construction were made out of steel in order to ensure the building's structural integrity and stability. They were prefabricated in Missouri and then shipped by rail to site. Starting with the columns, they are hollow rectangles formed by welding together a pair of channels, and then are found on drilled caissons. Well, why are the columns hollow? Some might think it would be unstable, but they're actually really strong because most of the steel is on the outer walls. This design makes them sturdy, but not too heavy, and this lessens the overall weight of the structure. Since the chapel is long, we put 11 columns on each side. Each column is 60 centimeters by 60 centimeters and spaced 7.2 meters apart. Now, once the columns were built, we put the pre-manufactured steel girders on top of them. These girders connect the columns to the beams and support the load of the building, transferring it to the columns below. Girders also allow for different building designs while keeping everything strong. As you can see in this picture, after the columns were fixed to the drilled caissons, the pre-manufactured girders were directly placed on top of them. However, do you realize that the girders are not straight but wavy? Well, this helps spread the weight evenly and lets more sunlight into the building. We call these wavy girders sinusoidal girders. Now that we've built the columns and girders, it's time to add the beams. Since our chapel is 26 meters wide, we need strong and long beams to support it. That's why we used I-beams made of steel because they're very strong and durable for their weight. And after making them in Missouri, we used cranes to lift the beams onto the girders and connected them with bolts and welding. We added a total of 22 beams, each measuring 60 by 120 centimeters on top of the girders. Now that the skeletal frame is completed, we added walls and a ceiling to enclose the inside space. Then, on top of the ceiling, we put another bigger concrete slab to make the second floor. Now that we've gone further into the details of the structural frame, let's go deeper into the interior walls of the Cadet Chapel. The first floor consists of two distinct sanctuaries, one for the Catholic worship and the other for the Jewish services. For both to coexist on the same floor, a dividing interior wall is essential, and that's what we see here. However, this wall's role extends beyond simply dividing space. It also serves as a sound barrier for the activities within each chapel, such as hymn singing and musical performances. If sound from these activities were to spill over, it would be highly disruptive to the services. Therefore, this interior wall simultaneously fulfills the function of space division as well as sound insulation. And to achieve this, two strategies were employed. First was the choice of materials. The wall is a composite of concrete and drywall, enhancing its soundproofing capabilities. Drywall, also known as plasterboard or gypsum board, is a panel made from gypsum and fibrous materials. Its affordability and durability makes it a popular material for interior walls. The material itself has a significant mass for its size, which helps to dampen sound, as it's harder for noise to pass through denser materials. Additionally, when installed correctly, drywall can be part of a system that includes air gaps and insulation, which can help to further reduce sound transmission. While typical buildings might either use concrete or drywall for their interior walls, the Cadet Chapel employs a combination of both concrete and drywall, further improving its soundproofing ability. Additionally, the installation of two walls with a usable space between them, essentially a storeroom, minimizes sound transmission between the two areas. This extra measure was necessary because it's quite rare for two different types of services to occur on the same floor. Now let's talk about the supporting pillars that we didn't talk about last week. Do you see those small pillars at the base of the chapel? It looks really small, but if you zoom in, it's pretty huge. You can also see that it's connected to the chapel's exterior aluminum panels by a hinge. Now what exactly are these? In the previous weeks, we thought these were buttresses because they looked very similar and had the same reason for construction, to support the weight of the chapel and disperse it. However, after finding more blueprints and plans of the construction during that time period, we realized that they were pillars that acted as the footings of the chapel underground. In terms of their appearance, these supports may appear similar to hinged joints due to their connection to the ground and the way they support the weight of the chapel above. Therefore, through intensive research, the buttress-like structures were actually a connection between the footings of the chapel and the aluminum panels that act as both the walls and the roof. These loads and pressure from the chapel were transmitted to the ground footings through these pillars, which resulted in the increase of stability of the entire structure. Well, you guys may ask, why are these pillars slanted? Why not build them straight up? Well, the reason why these were built leaning towards the chapel was because it was able to help in terms of aesthetics as well as structural stability, by distributing the weight more effectively and keeping its iconic angle. By angling the supports, the load-bearing capacity of the columns is optimized, allowing them to better resist vertical and lateral forces such as wind loads and seismic activity. Furthermore, the slanted appearance of the rectangular supports at the base of the Cadet Chapel serves multiple purposes, including enhancing the architectural design, improving structural stability, and contributing to the overall aesthetic appeal of the building. So far, we explored detailed information on the rebar and foundation, as well as the hinge foundation to support the roof. Next time, we'll delve more into the roof part connected to this hinge part, as well as the steel frame. Thank you for listening.